Thank you, Baldini Studio team, for the invitation. My name is Ciprian Popa. I'm a structural engineer from Romania. I graduated in Bucharest and followed a PhD study regarding designing glass structures in seismic areas. I'm a member of CNTC 129 and TC 343, which are the technical committees which work on adapting the Euro codes and translating them, nationalizing them for a specific country. And my country is Romania, and this is where I'm doing my work. As part of my PhD thesis development, I worked on developing an add-on for SCIA Engineer, through which we can calculate structural glass, and actually this presentation is just about this feature. Here is the agenda for today. So we'll briefly go with the capabilities of the glass add-on. We'll go with the status quo of the design codes for glass, and then I'll show some simple examples where this module makes sense to use in practical applications, and these models I will also share them with you. And then I'll go with some real case studies to see how customers used our solutions and how it brought success to their projects. And in the end, I will share with you some educational links in case you want to get more in depth with this aspect. As my presentation time is quite short and I want to have your full attention, this time the phones actually are also useful, as you can use them to scan the QR codes which are placed wherever I make references and send you to get more information. So you can grab now your phone and open the QR code application, as it might provide useful to study further whatever is of interest and you want to get further information. So just a few words about SCIA Engineer, why it is a very good solution for facade design. It's a certified BIM solution, and as it allows complex load assessments of any kind of load that is applicable to a facade. It allows static, dynamic, nonlinear analysis, and also it has integrated the design of materials which create these facades, such as aluminium, timber, composite, steel, masonry, and of course this glass part, which will go more in depth. And it also allows you to design the connections, which are a key aspect when working with glass elements. So it has many certification, among which BIM certification for import and export through Building Smart is very relevant, as it allows you to communicate both ways with architects or other engineers and with the detailing software. So just a quick overview of different types of loads that can be applied. It's a very general FEM analysis software, so you can create any kind of scenarios and type of loads applicable to the structure. It also creates automatically the combination, and also it allows you to make your own automatic custom combinations, especially when we deal with elements which are outside of the Eurocode, like the glass that I present today. In case we design infill panels, so like the windows, there are special provision where we have special combinations with softer safety coefficients, and this kind of approach is applicable in SCIA Engineer. You can create your own safety factors and use it to have an economical design according to codes. There are multiple types of analysis depending on the prerequisites and the models and whatever we use in our structures, so they get checked, they're available for performing once we do some prerequisite in our models. It has already integrated many design codes for materials such as steel design, and it has this transparent approach both graphically and fully detailed output. Whether you like tables or formulas, they are there for you to configure. And this is done also for aluminium, which is usually the support structure of the glass panels. And as you can see here, it can check very complex shapes that you can simply import from DWG, and you get Eurocode 9 integrated checks for all the structure that you model, all your curtain wall and so on. Now if we focus a bit on the glass part, there are three main directions that the add-on treats. There's the monolithic glass, a single layer of glass, then laminated glass with a more complex package of glass and foils, and the insulated glass, which is a more complex component, and this is where the code itself has provisions that are actually outside of the Eurocode, so it adds special actions that are only described here, and this is where actually glass is most used. So in most buildings, the glass, whether it's double or triple insulated, it's a requirement to get the green certification for and ZIB certification for the newly designed building. So as being the most current element, it's actually the most relevant type of element of glass that we might be required to analyze. Now a quick overview of the current situations regarding national codes. So in Croatia specifically, there is national norm NN53 issued in 2017, which gives some provisions and some conditions regarding the glass design of elements. So it's more like rules and set of conditions that need to be applied, like where to use laminated, where to use secured glass, and it works in conjunction with EN 612. There's a QR code if you want to download this code if you are not already familiar with this Croatian national code. And in relation with this 16612, which is the European code, all the formulas for structure analysis are taken from this code, so they are perfectly compliant. And I'm saying this because in our software we implemented this European code so that you can go with the glass project throughout all the Europe, and this European code is also valid in Croatia. It's valid in over 50 countries. Now regarding the Eurocode of glass, it's a work in progress status. It's a rough estimation that in 2028 it will be named as Eurocode. Until then there is a EN 19100 which is available for study, and it can be used. However, it's still not mandatory in any way, and it's mostly just an additional set of conditions compared to 16612, which is already implemented, and it's a valid code. So in the future it might be Eurocode 10 or 11 called, but for now it's actually a TC, it's a technical TS, a technical specification, EN 19100. You can look for it and find out more about this, but as I said, it's quite comparable with the current design of the software, which is according to EN 16612. So this is why we chose to implement this, and it's been implemented for over 5 years now, and it's available for European market. So for the current situations, there are just some simple provisions which might differ from country to country. What is specific about the glass? We need to perform geometric nonlinear analysis most of the time because of the slender panels, which means that we need to take into account the deformed shape, which generates an arch and additional capacity. So this means that we need to perform the analysis using large deflection theory. Now, to point out some differences, what you see on the left are the stresses from linear elastic analysis, and on the right side is from a geometric nonlinear analysis. You see that there's a different stress distribution between the two analyses, a distribution which is also mentioned in software like MEPLA. You see it on the right side, which is a reference software for calculating glass panes. So in SCIA Engineer we get similar distribution and results. So the idea is that if we go with nonlinear, we get a bit of higher deflections but smaller stresses, which are more close to the real measured stresses on different experiments. When we design a glass, we also need to think about connections because of the stress concentrators, and we can tackle this into SCIA Engineer using subregions and refining of meshes around the opening so that we can avoid things like this. These are pictures when I went bowling, but it kind of illustrates how sensible this interaction between a point connection and a glass pane it is. So in SCIA, we have the possibility of modeling subregions to take into account the soft material that is within the bolt and the glass pane. As I said, there are 3 categories, and the glass add-on is developed in this spirit with 3 direction: monolithic, laminated, and insulated glass. And insulated glass has double and triple insulated glass panels. It's implementing the stress, so it checks the capacity, the stress against the capacity, which is determined according to the settings that we do in the 2D data. We need to specify whether it's surface pre-stressed or it's just annealed glass. And also regarding the laminated, it has a converter. It calculates the equivalent thickness for stress and for thicknesses, so that in SCIA we take into account the correct thickness to have the correct stress distribution and make the check accordingly for stress. So everything is there. It's just some additional data that you impose for the element when you have to design laminated glass. And with insulated glass, similar approach. You specify some additional data regarding the panels, the gas cavity, and the software will calculate the isochoric pressure and the load sharing distribution between the panels. So if we jump into some examples now, you can scan it to download it. Here you have an example for calculating double insulated glass. The approach is that after making the geometry, it's like a pre-design, you'll get a calculation of the equivalent thicknesses, then you go again back with that equivalent thicknesses, get the real stresses and make the checks, and similar for the SLS. There is some input data that you need to specify regarding the foil, regarding the glass composition, and the rest software does automatically for us. Here is another example with double insulated glazing, this time fixed in point support, which you see here generates some stress concentrators. Again, you can scan the QR code to download this worked examples, and you also can preview check here how it looks, the load partition between the panels and the isochoric loads automatic calculation. I also provide here an example that you can download with parametric curved glass design, which is another interesting feature. So parametric means that the geometry you input through some attributes and you get the calculation and the update of the model very fast. And there are different scenarios with clamped balustrades. You see here with stress concentrators developed on certain points and areas. We can study and see directly the unity checks on the element. Also, you have here an examples where you take into account the failure of one of the panels. So you see how it redistributes the loads through the handrails and the different checks. These models also have engineering report behind, so if you have SCIA Engineer, you can open and explore more. With a triple glass design, it's similar, so you can model whether you have laminated or monolithic glass composing these panels, and it calculates, as I mentioned before, the isochoric and the load sharing coefficients, and you get everything integrated with the engineering report. So the main advantage is that it has European database for materials, and it can support the type of structures I've already mentioned. And now just some quick case studies. You have here glass canopy design in Croatia. If you scan this code, you can read more in an article dedicated. It's in a small town of Požega, and it was a nice project done by one of the users. And the advantage here, as you see, is that you can explore, you can have the instant geometry exactly with all the connections and see unity checks realistically in 3D, so you can identify stress concentrator, what's happened around those points. And also you can study deflections on a deflection model and take into account all the connections and everything that is inside this. Another example here from Austria, where we have this type of balustrade. You can see here that the steel is modeled as well, and aluminium can be modeled, and the glass. So we see in conjunction how these behave. Here is a quick preview of the model. So this is the advantage: you can model in 3D everything. And then you see the real stress distribution in conjunction with the connections, and you have also the advantage to study deflections, considering also the structure or the substructure, and taking account all those real stiffnesses which lead to higher deflections, so you can meet the reality better. This was another project from Romania this time, balustrade installed with an aluminium railing system on a balcony. So you can isolate in SCIA, and then you have the advantage of seeing in 3D deflections, and also you get 3D distribution, both for the glass. So instantly you can check the glass with an envelope of combinations. You can see the unity checks for the glass element, but also you can check the rest of the structure. You can see reactions, you can check the bolts, you can check the aluminum profile, as you see here, because everything is integrated in one go. And this is done with FEM analysis of these custom sections that you can provide yourself via DWG. The software calculates using fibers the real stiffness characteristics. Another project here was an aquarium design, post-installed in an old factory. They wanted to make like an aqua park. And here is what was the challenge: to model the connection. You see here that it's a quite complex steel shape. There are bolts that connect flanges, and it traps here the glass panels. The package, it was made of 5 layers of 10 millimeters and ionoplast foil. And here is how we do in SCIA. We have techniques like using rigid links so that we can connect the bolts to the profile, and the profile gets connected to the glass element. And we see that we modeled here exactly this concept of trapping the glass panel within the glass profile. And of course, having it integrated, it allows us to check everything. We can check the glass, we can check the concrete, we can check the aluminum, we can check the connections, everything in one go. So it's easy to make more iterations and make decisions. And finally, I invite you to have a look on this still work in progress, almost done construction. It's a symbolic structure which was nominated for SCIA prize for the user contest guide. This is just a quick preview of how it looks like, the FEM analysis, the final detailing from all plan, the architectural renderings, and we have actually a webinar dedicated to this. So I'm not going in more details regarding the structure, but it's actually more like what you'd see from a structure glass concept. So you see here glass columns, glass beams, the connections. So everything is done with shells, and it also allows this interaction of the plates and the soft material and the glass itself. And you can see directly unity checks, and also the panels themselves can be designed for isochoric pressures, for the load sharing distribution, and everything is integrated in the engineering report and can be previewed with very detailed formulas. So if you want to get more details about this building, I invite you to this SCIA webinar on 29th of May. You can scan here and register for free. If you are interested in getting also commercial details, please contact Baldini Studio to get a price list, and you also have the possibility of going with a free trial for 30 days, and you can also get some assisted free trials, a personalized demo. You just reach out to us and we'll be happy to provide you this. And also we have educational licenses. So if you have a SCIA educational license, you can use the software for free as well. I like to invite also engineers to have a look on the trainings that we offer. We have on-demand training, which means video lessons, pre-recording that you can watch at your own pace and rewatch whenever you need. There's a QR code here to send you directly to see our offer. And we also offer services like doing project training with you, or training your team exactly on the type of way you work on exactly on your specific project. You can scan here to get more details about this service. And we recently launched a support group where engineers, our customers, joined, and they communicate ideas, challenges, solutions. So it's a way to discover how other users are doing and get input not only from the producer of the software, but also from engineers working with it, testing workarounds and things like this. So I invite you also to test it for free, this group, and see the benefits. Thank you for your attention, and if you like to keep in touch, here are my contact details, and also you can follow us on social media to get more news from us. Thank you for the opportunity, and I wish you everyone a great day. Goodbye.